Unless you think life is a static structure, you have to admit that life evolves. And mankind had to have evolved from non-human animals. The first person to figure this out was Jacob Bronowski. Jacob shows, in his Origins of Knowledge and Imagination, how animal language is a single unified whole, one instructional statement. No questions or explanatory sentences. They have not split the nouns and verbs from this whole unit. Jacob gets this part from others, but he shows that understanding mathematics on a deeper level than just learning from already finished products, like numbers, equations, and geometric diagrams, show how nouns and verbs can be decoded out of this wholeness. Jacob notes the alarm calls of an animal. One alarm call is danger of bird. Another is danger of snake. And another is danger of big cat. What humans have done is abstract the more general concept of danger from the three instructions, and specialize, or idealize the three instances of cat, snake, bird. Today, or really, in the 20th century, archaeologists learned about the number sense of hunter-gatherers. And, we can see that this proves Jacob Bronowski's ideas of how natural language and mathematics evolved out of animal language. John D. Barrow, in his Pie in the Sky, mentions concrete words for numbers in different situations. Page 37 he shows an example of a pair of shoes, a brace of peasants, a yoke of oxen, and a couple of people. These are concrete versions of the abstract number 2. Page 38 he gives the example of a word for flat stone, smooth stone, another word for 5 fingers, and another for 5 people. These examples are like the different alarm calls for each situation, and really shows how the hunter-gatherers were not that far from animal language. Abstraction and idealization, as some mathematicians who like to wonder about where mathematics comes from, are two sides of the same coin. What was idealization at one time, becomes generalized into more generalizations, or abstractions later. But, what are these two concepts? Suzanne K. Langer explains in her Introduction to Symbolic Logic. The book's title hides that it gets into more than just showing the rules of deductive reasoning. It shows how symbolic logic can be derived from natural language. Her first chapter explains how abstraction works. Everything has a structure. This is quite a philosophical claim. The question is, can we continue to find structure all the way down? We've found that we can first find that matter is made up of atoms. Then, we find that atoms can be composed into electrons and protons and neutrons, and then there's neutriones, pions, quarks, antimatter. Today's quantum physics says there's a Planck's length, and it's far smaller than any quark, or Higgs particle. Is there any more structure between quarks and Planck's length? Stay tuned. Jacob Bronowski also makes this bold philosophical claim to make his understanding of how human thinking works. He says mankind makes a finite cut in an infinitely detailed reality. And, each finite cut can only be an approximation. But this is getting ahead of our story a little bit. Getting back to Suzanne K. Langer's Introduction to Symbolic Logic. Everything has a structure. A structure is a relation that connects two or more elements. One can do two things with a structure. One can find common elements or relations between two structures. This leads to abstraction, a common form of two structures. A relation can make sense between different sets of elements. But they have the same structural relation, and the same number of elements. So, we have an analogous structure. The other thing that one can do with structure is transform it. One could either switch out the relation, or the elements, and transform the structure from one thing to another. The transforming of structure is what gives mathematics the power to predict and to be the true key to the universe, and not mythology and art. Sometimes, one cannot transform one structure into another without looking beyond your current perspective. This is reflected in deductive logic. You can prove in one of two ways. There's the hypothesis and conclusion of a logical statement to be proved. And, you can either start with the hypothesis or the conclusion. Starting with the hypothesis generally entails Aristotelian syllogism. The famous Socrates syllogism, all men are mortal. Socrates is a man. Therefore, Socrates is immortal. Proving from the conclusion always takes the form of transforming, or re-expressing, and then moving the re-expression into the Gibbons list, from which the deductive syllogism is usually clear. The deductive proof from the conclusion uses the logical characters of and or not, implies, at least one, all equivalent of the above process of seeing the underlying structural relations to transform a problem. This is a bit like how we discovered the sun-centered cosmology. We didn't just build a spaceship, fly it to the polar regions of our solar system, and discover that the sun is at the center of the solar system. We derived it by noting odd things like the retrograde motion of the planet, the changing phases of the moon, and we logically derived that the sun must be at the center of the solar system and not the Earth. Suzanne K. Langer shows in her book mentioned above about seeing beyond your current perspective. In natural language, you have is used in a lot of different structural relations. Symbolic logic brings out these underlying structural relations. On page 56 of her Introduction to Symbolic Logic, she shows it broken down into 6 logical cases. The rose is red. Rome is greater than Athens. Barbarossa is Frederick I. Barbarossa is a legendary figure. To sleep is to dream. God is. The first ascribes a property to a term. The second gives an auxiliary value of asserting a dyadic relation. The third expresses identity. The fourth equates membership in a class. The fifth shows entailment. The sixth states existence without proof. I've noted some connections between what Jacob Bronowski shows in his Origins of Knowledge and Imagination and some of James Burke's connections. He notes that in agriculture, one has to have irrigation, pest control, and fertilization when clearing the fields. He notes in Chapter 2 that Guernica produced a vacuum, and the vacuum had a few effects like a fire would go out, you couldn't hear a bell in a vacuum, and mice suffocate in it. I find that these concepts that come about, when setting everything to zero, lead to what Jacob Bronowski calls inferred units. The 6 types of all mathematical concepts are derived from this process of seeing beyond our flat Earth perspective. Poetry also has analogies. Poetry calls it metaphor, simile, and personification. Jacob Bronowski notes that poetry and mathematics share this common property of analogy. I note that mythology is poetry. And so, I suggest that mathematics is the more general concept that elucidates the different arts and mythology. What I do in my Gospel of Truth here is show that one can explain how art and mythology work from the mathematical perspective rather than deriving numbers from art. Mathematics is the holistic viewpoint.